Everyone in fitness talks about how much protein to eat. Almost nobody explains what protein is actually doing inside the body, and that missing explanation is why most people's protein strategy is less effective than it should be. If this is your first time here, subscribe and share this with someone who is tracking their protein but not fully understanding why, or someone who has been eating what feels like enough and still not seeing the muscle development the training should be producing. This channel exists to give the explanation that most fitness content never gets around to providing. Protein has become one of the most discussed nutritional variables in fitness culture. Hit your protein. High protein diet. Protein first. It appears in every macro tracking app, every meal plan, every supplement advertisement ever created. The messaging is consistent and pervasive. And yet the actual understanding of what protein does inside the body, the specific biological process it participates in, the conditions under which it works most effectively, and the ways the standard protein advice fails to account for variables that significantly affect outcomes, is almost completely absent from mainstream fitness conversation. Most people tracking protein are doing so based on a daily total they found somewhere, distributed across meals in whatever way fits their schedule, sourced from whatever combination of foods is convenient, and timed around training based on whatever advice they last encountered. They are hitting a number. And they are assuming that hitting the number is sufficient. It is not always sufficient. And understanding why requires understanding what the body is actually doing with the protein it receives, at the cellular level, in real time, across each meal and each day, rather than treating protein intake as a simple input-output calculation where more is better and the total is the only variable that matters. What protein actually does? The cellular reality protein is not simply a building block that the body stockpiles for later use. The body does not have a protein storage depot the way it stores fat in adipose tissue or carbohydrate as glycogen. Protein consumed above what is immediately needed for active biological processes is either used for energy or converted to other substrates. It is not banked as a reserve of amino acids waiting to be called upon for muscle building when needed. This has a fundamental implication that most protein advice ignores entirely. Muscle protein synthesis, the cellular process of constructing new muscle tissue, is an event, not a state. It is activated by specific signals and requires specific conditions at the moment it is triggered. The two primary triggers are training stimulus, the mechanical demand placed on muscle that signals the need for adaptation, and amino acid availability, specifically the presence of leucine, an essential amino acid, above a threshold concentration in the blood at the time synthesis is being initiated. Below the leucine threshold, protein synthesis is not maximally activated regardless of how much protein was consumed earlier in the day. The cellular machinery that constructs new muscle tissue requires the signal and the substrate to be present simultaneously. Eating a large protein dose in the morning does not create a sustained amino acid availability that supports muscle building 12 hours later. The amino acids are processed, the anabolic window they create closes within a few hours, and the muscle building stimulus associated with that meal ends. This is why protein distribution across the day matters in a way that daily totals cannot capture. A person consuming 160 grams of protein daily in 2 large meals is activating the muscle protein synthesis signal twice. A person consuming the same total across 4 meals, each with sufficient leucine content to clear the anabolic threshold, is activating it 4 times. Over days, weeks, and months, the difference in cumulative muscle protein synthesis between these two approaches is substantial, and it explains why 2 people hitting identical daily protein totals can produce measurably different muscle development outcomes. The leucine threshold, the detail nobody mentions. Here is the specific mechanism that most protein guidance either does not know or does not explain, and it is the detail that changes how protein intake should be practically structured. Leucine is one of 3 branched chain amino acids and the one with the most direct role in initiating muscle protein synthesis. It functions as a molecular sensor. When its concentration in the blood crosses a specific threshold, it activates mTOR, the primary signaling pathway that initiates the construction of new muscle protein. Below that threshold, mTOR is not fully activated, and the muscle building response to that meal is blunted regardless of its total protein content. The leucine threshold is not fixed. It varies based on several factors that conventional protein advice rarely accounts for. Age is one of them. Younger individuals activate full muscle protein synthesis with lower leucine doses. Their anabolic sensitivity is higher, meaning the muscle responds more readily to smaller protein stimuli. As people age through their 30s and beyond, anabolic resistance develops. The muscle becomes progressively less sensitive to the leucine signal, requiring higher per meal doses to achieve the same anabolic activation that a smaller dose produced at a younger age. This means that the per meal protein recommendation appropriate for a 22-year-old is genuinely insufficient for a 42-year-old targeting the same muscle building outcome, even if the daily total is identical. Training status is another variable. Highly trained individuals have developed anabolic resistance through long-term exposure to training stimulus. Their muscles have adapted to the point where higher doses of both mechanical stimulus and nutritional substrate are required to push them into a growth response. The protein amounts that produce rapid muscle growth in the beginner phase are the amounts that support maintenance in the advanced phase. The practical implication is that per meal protein targets should be higher than most generic recommendations suggest, particularly for individuals who are older, more trained, or in a caloric deficit where the anabolic environment is already compromised. A target of 35 to 50 grams of high-quality protein per meal, from sources with complete amino acid profiles and high leucine content, represents a more physiologically grounded approach than the lower per meal figures commonly cited. Protein quality, the variable hiding behind the quantity conversation. Most of the protein conversation in fitness is a quantity conversation. Hit the number. More is better. The source matters less than the total. This is inaccurate in a way that costs people real outcomes. Protein quality, measured by the completeness of its amino acid profile and the digestibility and bioavailability of those amino acids, varies significantly across protein sources. And the practical consequence of this variation is that two people consuming the same total grams of protein from different sources can have meaningfully different amounts of that protein actually available for muscle protein synthesis. Animal-based proteins, meat, fish, eggs, dairy, contain complete amino acid profiles with high leucine content and digestibility rates that make a large proportion of the protein available for anabolic processes. Plant-based proteins, with notable exceptions, often have incomplete amino acid profiles, lower leucine content per gram, and digestibility characteristics that reduce the proportion of consumed protein reaching the bloodstream in forms usable for muscle synthesis. This does not mean plant-based diets cannot support muscle development. They can, with appropriate attention to protein source combination and quantity adjustment. But it does mean that someone consuming 160 grams of protein primarily from low-quality plant sources is not receiving the equivalent anabolic stimulus as someone consuming the same total from high-quality complete protein sources, and treating the two as equivalent because the gram count matches is a meaningful oversimplification. The Protein Digestibility Corrected Amino Acid Score, PDCAAS, and the Digestible Indispensable Amino Acid Score, DIAAS, are the research-supported metrics for protein quality. Understanding that not all protein grams are created equal, and adjusting source selection and quantity accordingly, is the layer of protein strategy that moves the conversation beyond hitting a number toward actually optimizing the anabolic environment the number is supposed to create. The timing question, what the research actually shows. Protein timing has been one of the most debated topics in sports nutrition, and the debate has produced more confusion than clarity because the popular framing of the question has been wrong. The question is not whether protein timing matters. It does. The question is which timing window is most important, and the answer is not the one most fitness content has emphasized. The post-workout anabolic window, the period immediately following training during which protein is said to be urgently required for muscle recovery and growth, has been shown by more recent research to be less narrowly critical than the fitness industry implied for decades. Protein consumed in the hours around training is beneficial, but the acute urgency of the 30-minute post-workout shake has been overstated relative to the importance of total daily intake and per meal distribution. The timing window that research supports most strongly for muscle protein synthesis optimization is the pre-sleep period. The body's overnight fast is the longest protein-depleted period of the day, and it coincides with the peak of growth hormone release and the elevated muscle protein synthesis rates associated with deep sleep recovery. Consuming a protein source with high digestibility before sleep, casein, found in cottage cheese and milk products, is digested more slowly than whey and maintains amino acid availability across a longer window, extends the anabolic environment into the overnight recovery period rather than allowing muscle protein synthesis to be substrate limited during the most hormonally favorable recovery window of the entire day. Most people eat their last protein-containing meal at dinner and then fast for 7 to 9 hours. For someone whose goal is maximizing muscle protein synthesis across every available window, that nightly fast represents an overlooked opportunity, one that a pre-sleep protein strategy directly addresses without requiring any change to the rest of the day's nutritional approach. Conclusion: protein is not complicated at the surface level. Eat enough, from quality sources, distributed across the day, around training. That summary is accurate. But the depth beneath it, the leucine threshold, the per meal activation requirement, the quality differences between sources, the pre-sleep timing opportunity, the age and training status adjustments, is where the strategy either works at its full potential or underperforms relative to what the same total intake could produce with better structure. Most people are hitting a number. The people whose muscle development matches their training investment are hitting the right number, in the right doses, at the right frequency, from sources that actually deliver what the muscle protein synthesis process requires. That is not a more complicated approach. It is a more precise one. And precision, applied to a variable as central to body composition as protein intake, produces compounding returns across every week and month of consistent training. Structure the protein around what the biology actually needs, not what a daily total suggests is sufficient. The difference in outcome over 6 months is not marginal. It is the difference between training that produces results and training that produces the performance of effort without the body composition change that effort deserves. If this filled a gap that daily macro tracking never addressed, subscribe and share this with someone whose protein strategy is built around a number rather than an understanding of what that number is actually supposed to accomplish. Every video on this channel is built to give the real explanation, the one that changes how the information gets applied.